Hello, this is Stephen Rakusik with SDPB.
And I'm Blaise Rakusik, currently a medical student at the University of Nebraska Medical Center.
And if you're wondering, yes, this is my son. Today we're going to be doing the dissection of the sheep brain, looking at the internal structures, also identifying the function of those, which you're going to be using the human function, and also some of those diseases.
Yeah. So the first thing, so when you get the sheep brain, depending on which one you get, more or less this could be removed. But we talked about the meninges a little bit in the last video. But so this is the
Should I hold that for you?
Yeah, the connective tissue covering that you have to get off the brain before you start cutting into anything. And so this can be kind of a pain to start. I think what might be the easiest is, so this dura mater is this like thick tissue that you see on top. If you get one spot kind of started with the scissors potentially here, like here we go. So once you get one spot started, then you can kind of start pulling it up, reflecting it back pretty easily. It's going to come off really easily because it's going to be very separate from the pia mater below. And so you can kind of, and it might work to have, a couple students working together like this, and you want to just pull it up and then just be careful not to actually, gash into the brain itself too much with this. But we're going to kind of just remove this section by section. And I was kind of hoping we might see a little. So
flip the other way, maybe. So you can maybe.
Yeah. So you can see here really well this like thick connective tissue that's the dura mater. We may see a little bit of the arachnoid mater that we talked about, where it's a little bit spiderwebby as we pull this off. But again, it's not super easy to see a lot of times in these.
A lot of times they don't show it, too well. If you do get a student that has one really well, I would have all your students look at it.
Yeah. So this one isn't really. We're not seeing too much webby stuff as we're taking this off, unfortunately. But that's just kind of, each specimen's gonna be a little bit the same, and that's generally not a super easy to identify structure. So we'll show a removing part of this, then we have one that we can grab that we remove more of, so we don't. And so this is gonna take some time.
Process, yeah.
But go slow, and the slower you go and the more you remove, the better your dissection is going to look at the end and easier to be able to see stuff. So
should I grab that other one then? Maybe?
Yeah, so at this point, we can see the shininess here. So the shininess on top of the brain itself, this is the pia mater that we talked about, and that's going to be very hard. You can't really necessarily remove that from the brain tissue itself, so that'll just kind of stay on there. Okay, so now if we cut to this other brain here, we removed a little more of that dura mater. We kept a couple spots here. So you'll see, and this is actually kind of, so you see like this almost like a tent type look here. So this is where the dura mater will separate the cerebellum from the cerebrum. And so this can be kind of a pain to get out of here. So we wanted to wait to remove this till we showed the camera here. So what you can do is you grab it with the tweezers here again, the forceps, and then it comes off pretty well intact. Here you can see a little bit of that spider webbing actually, which might be a little bit of that arachnoid mater. And so this is going to be really, when you're going to actually cut the brain in half, this is going to be next to impossible to cut through with like the plastic knife we're going to use. And even with a scalpel, it'll be kind of hard. So that's why it's good to get a lot of this off before we try to actually cut.
We should mention too, a lot of times we use the scalpel in a lot of dissections we've had on our site. For this one here, we're actually maybe suggesting a plastic knife, or even maybe a kitchen knife if you have one of those in the classroom, the lab.
Mm-hmm.
The thing bad about the scalpel is when you go to cut it, a lot of times you get jagged edges, and it's hard to identify some of those parts.
Yeah, I'm having you move your hand back a little bit here. So you want to be careful when you're cutting this stuff. You don't want to cut your lab partner's hand, so just be aware of where the fingers are at.
Actually, we're just holding it here for the camera, and I would not suggest having
you
students.
want to have it.
Yep. You want it down on the
dissection tray.
Yep. Yeah, we're just showing this for the camera here to hold it. I can pull back there.
Okay, so let's take a look at the side here. So we have, once you have a good portion of the dura mater removed, that you can make your cut, you may have to also remove a couple of these other ancillary structures. So we talked a little bit about how you can see the back of some of the nasal structure here, and then off to the side here, back of where like the eye stalk would be. And so for these, and again, some of the brains might have them depending on how you order them, but this can all kind of be, and it kind of comes apart fairly easily. And if you can try to, like here, I'm trying to kind of save the olfactory bulb, and this one's going to be maybe a little harder to save on this side, but there we got both olfactory bulbs saved.
Nice.
And then a lot of this will be, very intertwined with the dura mater, so it should come off fairly easily. One thing you'll have to cut for sure is the optic nerve, and so you can see this one right here, which we'll cut, and hopefully we'll have a decent amount of the chiasm left.
And one thing I mentioned too here, maybe if you are ordering the full brains, it also is nice to order some of the half brains.
Mm-hmm.
Those are always cut real nice by the supplier, so for reference. So if you do remove something accidentally, you have some of those half brains on hand too.
Yeah, and so when you're looking at actual brain structures, it's easier to see without those on there. But it is kind of interesting to see how the the optic nerves where that fits into the optic
Absolutely.
or the optic nerve fits in the eyeball structure, and then the olfactory bulbs will fit into like the nasal structures.
Especially if you're also dissecting the eyeball too. It's nice to have that reference point.
Mm-hmm. Okay, so we got there
Move this
a lot of, and this actually you can see here really well, this the dura mater here, how thick it is, and it covers every like infolding of the brain too, and how it all fits in there.
I can move this out of the way for you here.
And actually, can you grab that thing one more time? I want
Yes,
to
absolutely.
mention one thing with that. So when we were talking about the meninges, and we'll cut into when we see the ventricles, we talked about the cerebrospinal fluid flowing through the subarachnoid space, the area right below the arachnoid mater. And this shows us kind of nicely how when we went to pull this off of so this is like the front portion here. When we pulled this off the brainstem, we saw where it was attached to the spinal cord.
Yeah.
And you can see how it's all continuous. So the cerebrospinal fluid, the CSF, is flowing in the subarachnoid space around the brain itself and down through the spinal cord.
It's the entire way down. So.
Because that's all considered central nervous system.
It's like they do a spinal tap that could check the fluid anywhere.
Yeah, exactly. So if you're concerned about meningitis or some sort of an infection of the meninges, you do like a lumbar puncture. So that would be and then you try to look for culturing an organism in that space, because if you have an infection in the brain, you'll see it in the spinal cord.
Easier to
So-
access through the.
Yeah, because that's a good safe place. So the reason you do a lumbar puncture is because it's below where the spinal cord's at. It wouldn't really be a good place to tap into that in the brain here without hitting something important.
Okay.